Welcome to this session where we will be talking about working with your portal using Arcgis Runtime. My name is Devesh Goyal, and I'm joined up here by my colleagues Nathan Castle and Vijay Gandhi. And all of us work on runtime development here in Esri, but we have slightly different focuses in terms of technology platform. So Nathan focuses mostly on .NET and Xamarin. Vijay works with Android and Java, and I try to work a little bit with iOS and Mac. So broad perspectives on technology and variety of different skills up here, but we're still working on building the best runtime for you to use. So that's a little bit about us, but we'd like to know about you guys. So how many of you in the room are developers? Everyone. That's great. This is not a session for managers. I see one guy left. Good. How many of you have used Runtime before? Quite a few of you. All right. That's good. And how many of you have used JavaScript API? Oh, OK. About the same. And how many of you are .NET developers? OK, that's maybe half of the room. How many of you are Java or Android developers? A few. What about iOS, Mac OS? A few. And Qt? All right. Great. It's good. Looks like we have a mixed bag. How many of you have used portals before? OK. How many of you have developed with portals? Some of you. All right. Good. You're exactly who we need you to be, because this session, we're going to talk about developing with the portal. But for some of you who haven't used Runtime or the portal, we'll start off with just a brief overview to talk about those technologies and where they fit into the landscape of Esri tech, because there's a lot of tech out there. So we'll put it into context. And then we'll go through the developer workflows of how do you access a portal from your native apps? How do you consume content from the portal in your apps? And how can your apps contribute back to the portal and create new content? So let's start with Runtime. For those of you who haven't used Runtime before, don't know where it actually fits, well, Runtime is really just a collection of software components that bring the spatial and mapping capabilities of ArcGIS to modern desktop and devices like phones and tablets. These software components we build using C++ because it allows us to make them portable across a wide variety of different technology platforms. But also because C++ runs closest to the metal, so it has really good performance. And we can actually utilize all of the hardware on the device to do our work. Now, even though the runtime software components are developed in C++, doesn't mean that you as developers need to use C++ to use them, because we expose them to you through higher level programming languages and APIs that feel natural on your technology platform. So if you are an Android developer, we expose the runtime through Java APIs. If you're an iOS developer, through Swift. And if you're a Windows developer, we expose it through .NET. So it's a win-win-win for us, right? We get portability because of C++. We get performance because of C++. But you guys get developer productivity because you can use these high-level APIs, these nice programming languages, and the best tools that are available on your development platform to build your native apps. Now, even though we have all of these different APIs, we strive to keep the same core capabilities across all of them. And we even try to use the same conceptual patterns and the same programming styles, so that we can do a session like this, where we have people from different technology backgrounds, but we can logically talk about an area of functionality. And it'll also help you guys, because many of you may be tasked with building an app for more than one platform. And so the runtime skills you develop working with one of the APIs, you can instantly transfer over to the next API. You just need to change the syntax and the UI style, maybe. Or even if you're building just for one platform, you can work better with coworkers in your organization who might be working on a different platform, because the runtime concepts are the same. So how do you get one of these APIs? Well, you go to developers.arcgis.com, And we build an SDK for each of these APIs. So we have 6 SDKs out there. And it's not just about the APIs and the software components, but we provide a rich set of resources, like an API reference that's well documented, telling you what those methods and properties are for, a conceptual guide that's taking you through the workflows and talking about it at a high level. A lot of samples so that you can borrow from our sample code and look at best practices and actually see the thing work even before you've written a line of code. And all of that's available at developers.arcgis.com if you go to the homepage of one of those SDKs. So that's about runtime. Now, just talking about the Arcgis platform as a whole, it's evolved quite a bit over the years. And it started off really with a very simple desktop pattern, where we built applications for the desktop that allowed GIS knowledge workers to work with local data sets. And that was great till their GIS work needed to scale throughout the enterprise, and they couldn't just work with files that were locally on their machines. So we progressed to a server GIS pattern, where people can put that data in a relational database or publish them as services, and then everybody in the enterprise could collaborate and use them, and it was not just the data sitting on someone's machine. Well, now we've progressed to the next level of that, which is the Web GIS. And the desktop and server patterns feed into this Web GIS, but the Web GIS is built to scale beyond your enterprise. So you can reach out to citizens and other constituents and work with a wide variety of apps, be it native apps or web apps, and really be able to share the information that your GIS department produces. Portals are a central part of that Web GIS model because they organize your GIS assets, like maps, scenes, layers, services. And they enable discovery for anybody who wants to use it. So no longer is the data locked away in a database or sitting on someone's machine on disk. It's available for anyone who connects to the portal. It enables discovery, but it also empowers people to create new data sets, new maps, new scenes. GIS departments get this request all the time. Hey, can you build a map for me that shows this so I can use it in an app? And it's been really hard to sort of share that map and take it where it needs to go. But with Portal, you create that, add it to your organization's portal, and now it's available for executives, in dashboards, for knowledge workers, through native apps, web apps, wherever that data needs to go, and wherever people need to work with it to get their job done. So the Web GIS pattern can be implemented in 2 ways, 2 deployment ways. One is where it's available in the cloud. This is what we call Arcgis Online. And the other is where it's behind the firewall in your premises, which we call Arcgis Enterprise. But regardless of the deployment model, the portal software is the same, and your user's view of the portal is the same, and a developer's view of the portal is the same. So which one should people use? I mean, there's a whole session that's dedicated to that, to just talking about those options, but if you had to distill it into one brief slide, typically you'll use Arcgis Enterprise if your organization's not ready to move to the cloud, and you want to host the software on premises behind a firewall, because you have strict governance requirements, you have SLAs, or you may not have an internet connection that goes beyond your firewall, and you need everything local. You may use Arcgis Online if you don't want to deal with any of those administrative tasks, like patching the software, making sure it scales, because Arcgis Online is built for scaling, and it auto-scales depending on the use of the system. So it makes administration and scaling really easy, but it requires you to embrace the cloud. So we talked about Portal being like a central management system or a content management system for all your geospatial data. And it's what apps connect to find that data. And what makes it possible for a wide variety of apps to work with your portal is because all portals share a common and uniform geo-information model. So right at the top is the concept of the organization to which the portal belongs. And within that organization, there are items which represent the content of that organization. And that item can be a web map, a web scene, can be layers, or can be applications. And those items can be organized into groups. Also, the organization may have users, and some users have access to some of those items depending on how things are set up. So 20,000 feet overview as developers is this is the information model of everything that's behind a portal. And this information model is exposed to everyone through a REST API. And that's what the JavaScript API builds on top of, that's what Runtime builds on top of, and that's what Python builds on top of. And all the apps that are built with these technologies end up using that geo-information model through the REST API. So let me give you an example of a portal that we set up for this session, for those of you who haven't seen it. This is a web application, and the portal is called geobrew.maps.arcgis.com. It's a hosted portal that's living on Arcgis Online. And the web application allows users to explore information in the portal. So right here, I can see all my featured maps that are available in the portal. I can go to the Content tab and see all of my content, so all my maps, layers, and scenes. I can also see my folders, which allows me to group all of my content nicely. I can see the groups that I belong to and the items that have been shared to me through those groups. And then I can also see just the broader set of items that have been shared to everyone in the organization, even if they're not part of a group. And this is the web application that typically people use to access portals, but we also provide native apps that work with content inside the portals. For instance, Explorer for ArcGIS, there was a session in this room just before. There was a native app for iOS and Android that allows users to sign into their portal and access all of their content from native apps. Workforce for ArcGIS works with projects that you create in your portal for field workers, so you can assign tasks to them and see where they are. Collector works with maps inside a portal that have been enabled for data collection and taking offline. And all of our apps work with that portal information model, and so can your apps do the same. Now, it's not necessary for you to always build a new app if you want to use that information in a portal. Try to use one of the apps that we provide. But you may find that you have some special needs for workflows that you need to implement or integrate with business systems and bring that information into the app. And in those cases, you'll build a custom app that has access to the portal, but also goes a little bit beyond what our apps do. So in those cases, let's talk about you as developers. What do you need to do to access a portal? Well, it's really simple. We provide a very coarse-grained API to the portal information model, and it starts with a portal object. You create a portal object, give it a URL to your portal. Now, just creating the object is not enough, because in Runtime, we have this pattern that we call loadable, which is anytime an object needs to access something from disk or something from the network, where it could take time for those things to happen, it needs to happen asynchronously, so that it doesn't block the main thread of your application. And we've formalized this using the loadable pattern. So once you instantiate a portal, for it to connect remotely to your backend systems, you need to load it. Once you load it, if your portal is not set up for public access, you'll need to authenticate, provide some user details on how you want to connect to that portal. And there are a number of different authentication schemes that are available to administrators to set up their portal. We support things like container-based security using HTTP, or integrated Windows authentication, or even signing in using digital certificates that might be available on the client device. We support OAuth, which is a really easy way to hand off all the authentication to the backend system, where the app developer doesn't need to handle the username or password, and it's incredibly secure, and allows you to integrate with third-party providers, identity providers like Facebook or Google Plus for social logins, or even enterprise identity provider, like your Active Directory or Okta or LDAP. And once your app's connected to the portal, through after getting in all the user information, then you can access details about the user who connected and customize the app for them, like show their thumbnail, see what role they belong to, can they create data, or are they only allowed to consume data, etc. And then access that user's content and display it to them. So with that, let's take a look at a demo that shows how you can connect to a portal. So I have here a iOS app. It's pretty simple. It's got 2 scenes in it. When you launch it, it asks you to sign in with this big, bold sign in button. And when a user signs in, we show the second scene where we show his thumbnail and some details about the user who just signed in. So let's go ahead and see what we need to do to make this application work. So what we're doing here is creating. Oh, I'm sorry. Let's try this. So let me back up a little bit. This is the scene that I was showing you where you just got a big sign in button that we'll write some code for that when user taps sign in, we'll connect to the portal and populate some details of the user. So this is that sign-in function that gets called when the user taps on the button. All we're doing is creating a portal object. We're giving it the URL to our portal, and we're calling load on it, right? And so let's go ahead and run this and see what happens. So I'll go ahead and tap sign in, and you see I get a alert asking me to sign in with my username and password. Now I don't have any code in my app that shows this UI, and that's because the runtime is an authentication manager that's looking at all the connections that are being made, and as soon as it detects a connection that requires authentication, it'll either challenge back to the developer and say, here's your challenge, display some UI to have the user sign in. But of course, in my app, I'm not handling that challenge, and it detects that and shows some UI by default. Now, I can go ahead and input my username and password here, but typically we don't want people to be providing their credentials to a dialog of the app, because the app developer could inspect it or do something nefarious with it. What we really want to do is use OAuth, because then all the credentials go straight to the backend portal and the app developer never gets to see them. To do that, all I need to do is provide the runtime with some details, like what is my client ID for this app, and what is the redirect URL that my app uses, so that it can come back to me once the user's finished signing in. Now I've added those configuration details. There's one more thing that I need to do, which is if the portal loads successfully, then I'll just move on to the next scene where I can show the user profile. Let me go ahead and sign in this time. And now, what you're seeing is I'm getting an OAuth login page. Now, this is not UI of my app. It's a web page that's launched in process using the Safari browser, where the user can sign in, and the credentials are going straight to the portal. For some reason, my hardware keyboard is not working, which means I am going to have to give you guys the password to this account. That's okay. We'll change it right after. Close your eyes. Oh, great. I gave you my password for nothing. Maybe I gave you the wrong password. But basically, you see the OAuth login dialog came up. I put in my credentials, and if things had worked magically, I would have gone to the next scene where I would see who the users that logged in. So it's really simple. Steps are create a portal, load it, and set up your OAuth configuration so that your app can use an external browser to do all the authentication. Question?
Redirect URL is where it goes if successful?
Yes, correct. And this is something that you need to set up your app to listen to. So that's the name of my app, and it's registered with iOS so that in case the browser redirects to this, it'll launch my app. All right, so that's about connecting to your portal and authenticating users. With that, I will pass it to my colleague Nathan, who's going to talk more about accessing content from the portal. No, that's fine.
So, can everyone hear me okay? In the back? All right. So let's talk about accessing content in a portal. So first I'm going to talk about content and the types of content that can be in a portal. Then I'm going to show a demo of a pretty portal browser using our Runtime SDK for .NET. And then I'm going to show you the code and how you could implement that portal browser yourself using our APIs. And then finally I'll cover some other notes about the queries and some other things our portal can do for you. So we talk about a portal having content. What is a portal item? So a portal item has content. So that can be binary content, text content. It could be a file. It could also be a web map or a feature service. A portal item also has a type. So this is really useful for your runtime app to figure out what you're working with. Because whether it's a PDF or a web map, it's going to be represented by a portal item, and you need to know how to handle that. There's also metadata, so the title, the description, when it was updated, when it was created. There's a thumbnail, and there's sharing information. So is it shared with a group? Is it shared with an organization, a user, or even the World Wide Web? So I like to think about portal items being in one of two broad categories. In the first category, you have these ArcGIS types. These are things like map services, web maps, etc. So and you can see in the screenshot from ArcGIS Online that the portal actually knows what a web map is. So it can give you intelligent suggestions like opening it in a map viewer or opening it in desktop. And in the other category, you have things like PDFs, Word documents, things that you can still store in your Web GIS. That's still valid content, but maybe the runtime or the portal doesn't really know what to do with it, but you still can organize it and share it and manage it the same exact way. Now, one advantage to the first-class citizens, these ArcGIS types, is that runtime often has content constructors. So if you're trying to make a map from a web map, that's just one line of code. It's very convenient and straightforward. Our map viewer can't necessarily show you a PDF, so we can let you download it, but that's about it. So now I'm going to move on to the demo. All right. So this is a native Universal Windows Platform application. The advantage, or I'll talk about what you see here. This portal browser will work with any portal. It defaults to the demo portal we're going to show you. And I'm going to log in. I want to point out that because Runtime provides this common base of functionality, the code to get this OAuth prompt on Windows is very similar to the code that Devesh used on iOS. So if you're working with multiple platforms, that's a very easy transition. I'm going to log in and hope that when I've logged in, no one has done anything funny with our password. All right, so we've logged in, and we have 4 tabs. So we have Featured, My Content, My Groups, and Search. I also want to point out that because we've logged in, we have that user object, which has the username in the top right and a picture. So let's move over to my content. You've asked the user to log into your portal, or to their portal. They expect to have that experience of having logged into their portal. So they have their content, and they expect to be able to access that. Now, to get their list of folders, this is a list of folders right here. That's one line of code. That's one call. You don't have to worry about making a custom query to the REST API. It's very straightforward with our functions. And then to get the items in each folder is a very similar call, also just one line of code, which is very easy. Now I'm going to move over to featured. An organization can define a set of featured items, and when you log into a portal online, that's what you see. You see those featured items. So it's a really powerful capability that when you make a portal app, you can actually get the same exact experience when you log in, which is to show those featured items. I'm going to open one of these items. Now we see a map immediately pops up. This was using the content constructor. So once the user selected that portal item, that was just one line of code to then show it in the map. On the right, we see the title. We have some metadata. So it's a web map. It's been publicly shared. There's this HTML content. This is the description. We're showing it in a web view so we can see that rich formatting. Let's go back to my groups. A portal could have thousands, tens of thousands, or even millions of items. And you want to be able to organize that in a way that makes sense. I don't want to have to go searching for the maps that I care about based on my role every single time. So we see the user we've logged into is in the Medicare group. And to get the list of groups that they're in, you've actually already gotten that when you've logged in. That's a property of the user. And then you can query the portal items based on what group they belong to. Let's move over to search. For the demo, I'm going to type in costs. I'm interested in maps relating to costs, if I can type today. All right, so we see there are 3,000 results, or 2,000 results. That's a lot. We don't want to load every single one of those each time. So we can paginate our queries and be able to intelligently handle the millions of results we're going to get. Now, my user is in the Medicare group. There's a pretty good chance I'm looking for maps related to Medicare, so I can filter this query to only groups in that, or only items in that group. And then, as before, I can open that, and it loads very quickly, and I can see that content. Now let's move over back to the slides, and I will show you how you can implement this yourself. All right, so we logged in, and we immediately saw my content. To get the user's content, that's just one call to portal.user.getContentAsync. That's one of our convenience methods. That returns a portal user content, which has a list of folders and items. Now, once you have a folder you know about, you can get the items in that folder with essentially the same call. I want to point out these are using the async await functionality in .NET, and there are platform specific versions of that following the loadable pattern. Let's talk about those content constructors. So if you already know what a portal item is, and you already know what you're expecting, you can pass it to the constructor of the relevant runtime type, in this case a map. And we have these for a lot of things, which is really awesome. It becomes one line of code. I also want to show you, you have a portal item. It could be a PDF. If you pass a portal item representing a PDF to a web map or to a map object, it's not going to make sense. You're going to get an exception. So what we do here is we actually use link in .NET to filter and make sure that the item, in this case a featured item, is actually a web map, and then I use it. So I showed you the featured items in the portal. And that's a really powerful way to make sure your app feels like a cohesive part of the Web GIS. So when a user logs into the portal online, they get one experience, and you log into your app, if it's appropriate, you can give them a very similar experience. I also want to talk about default base maps, because that's another key convenience method we provide. Often a portal will define certain base maps that you want to use in an editing experience. So not relevant to a portal browser, but if you're going to let someone make a new app, you want to give them base maps that make sense. And we let you do that. Groups content. A user can be in 0 or many groups, and you get the list of the groups that they're in as soon as you log in. So that's essentially 0 effort, you already know. You can query items in a specific group. So we see here a query. We have this static constructor for the portal query parameters, which makes it very easy. You don't have to go find out what the REST API standard is and figure that out. We just do it for you, which is very convenient. And so we use this type of query in both the My Group section, but also when you give a search experience, you can query that way. Now, I didn't show this in the portal browser demo, but you can also query for all of the groups in a portal. You can search by owners, by titles. Again, this is one of those queries that's very easy, low effort in the runtime. Now, in the example of our demo, we only cared about web maps. And if you know you only care about a certain item type, you can make that query, which is really awesome. And there's a bunch of variations on this. So there's items of type in a group. There's items of type belonging to a certain user. In this case, items of type web map that match the query metacare. Now, I showed off pagination in the demo. Every query that I've shown so far, with the exception of the convenience methods, lets you paginate them using the limit and the start index properties. And really, it was pretty awesome being able to implement that in just a couple lines of code rather than having to muck around with REST queries. And then I gave you a GIF just in case the demo didn't work, and I can prove it to you and remind you, here it is. It really works. Now, I've talked a lot about some of these convenience methods we give you, and I like to think about it in terms of like two broad groups, which is you build and execute a query, or you use one of the really nice convenience methods that gives you a predefined query, like featured items or base maps. One thing to point out is the query parameters object is the same for all different types of queries. You want to make sure that if you're querying for groups, that you use the find groups async method and not the find users async, because it's not going to make sense. You want to make sure that you're searching for the right things, which again, it's pretty intuitive and generally very easy. So I talked a lot about our convenience methods, in particular the portal query parameters object. Ultimately, it just wraps the REST API. Here you see on the screen this string here. That's the query that the portal query parameters constructor gave us. So if you wanted to, or if you need a more advanced query or a more powerful query, you can go in, you can take the one we generate for you, and you can edit it. Or you can start from scratch, and you can always just make a hand-built query following the REST API specification. Now, that is documented online. If you go to developers.arcgis.com, you can learn all about that and the options you have. Now, I want to touch on one last thing. Portals can make a variety of services available to you. For example, elevations, routing, traffic, geocoding. If a user logs into their portal, they're going to expect that they're using that portal's resources. And we have APIs available to make it really easy to find out what those are. I'm not going to show the code because it's pretty specific to certain workflows. But again, it's very straightforward and documented online. So that wraps up my content. I'll hand it over to VJ to talk about creating and sharing.
Thanks, Nathan. So Nathan showed you how you can read data from portal and then show that in your runtime applications. In some cases, you may also want to create your own content from the runtime application. You may also want to update your own content. And then once you're done with that, you may want to share all that new content items with different users. So we have you covered for that as well using the Runtime API. Let me show you how. So depending on the type of the portal item, there are like two ways to create a portal item. So one, which I call the coarse-grained API. So in that, we have an API type corresponding to the corresponding portal API type. So these are like the first-class citizens of the Runtime API. So using that, you don't have to worry about specifying metadata like the type of the portal or the content. You just use our high-level API, and then we'll take care of rest. We'll take care of like marshaling the data into appropriate format and sending that out to the portal server. Another option is to, another way, depending on the portal item type, is to use the fine-grained API. So in this case, you would work with, we have a class called portal item, so you'll work with that. So in that case, you have to specify the type, and you also have to specify the content. So let me give you an example. Web map portal item type is a very common example. So if you want to create a portal item type of web map, you will create an instance of Arcgis map using the Runtime API. So in this case, we will derive the type, in this case, which is web map from Arcgis map. And then we provide API to set the content on this map. So a map is composed of like many different types of content. So one of those is a base map. So we have a class called base map. So you would create like a new instance of base map, or you can also get base maps from your portal. So every portal has a default base map. You can use that. Or the portal administrator can configure different base maps depending on your use case. And then you can use any one of those configured base maps and set that on your instance of Arcgis map in the Runtime API. So in addition to base map, a map also consists of layer. We have like different layers. A feature layer is an example if you want to show like different points of interest. So you can create a new instance of our feature layer and then add that to the map. Again, so all of these things are part of the API. So you would work with that.
Question.
Yeah.
If you're picking up the portal's default, does it get stored in the web map so that if you change your portal's default to something else, it's not going to be updated, right?
No, it doesn't get stored in the API web app. Yes. Yep. And then once you have set up all the content that you want to create, you simply call save methods on the corresponding type. So for Arcgis map, if you want to save it as a new map, you would call save as async. And if you want to update an existing map, you would simply call save async. Note that we are trying to follow the same kind of naming pattern across APIs. So Nathan showed you some APIs, and Devesh showed you some APIs. They all had those async in their method name. So any operation that makes like a server call would be like an async operation. So let me show you a demo here. So I have an Android app. Let me run that. So right now we are looking at a map that I created using the Android API. It has a base map right now, which is a dark canvas vector. So I can change that. So let's say I want to use one of the base maps that was configured for this portal. So I'll click on this icon, and it shows up all the different base maps that are configured. So I'll select one, let's say light gray canvas, and then switch here. So it changed the base map of this map. So in addition to base map, I also have a feature layer, which shows health insurance. It shows data about people who don't have health insurance categorized by state. And I can update this. So I'm going to click on this icon. And then it started this process of uploading this map to the portal. And then if I go to my web browser, which shows the content right now, and then refresh this, you would see that it added this item that I just uploaded. So now I can open this in web browser. And then if I look at the content of this by clicking on this, you would see that it has the base map that I used, and it also has the feature layer. So all of this was uploaded with one click. So let me show you some source code for this. So I saw that we have some people who use Android. Have you guys tried Kotlin? So Kotlin is a new programming language which you can use to build Android applications. So all the samples that I'm going to show you today, that's written in Kotlin. So as I said, so when I want to create a new map, I simply create a new instance of Arcgis map. And then after that, I want to set up a base map. So if I want to use a simple base map, I can simply call basemap.create, the type of the base map that I want. Another option I showed you was to get all the base maps that are configured in the portal. So for that, it's like a two-step process. So the first step is to get the group that contains the base map. So I basically create a query object. And then on the portal, I call this method called findGroupsAsync with that query. So that would return the group that contains the base maps. And once I have that group, I create another query object. And then I pass these parameters, which is basically the group ID and the type is web map. And then I call findItemsAsync. So that will return all the base maps that are there in the group. And then I can choose one of those. OK, so after I've set up the base map, I want to set up a layer. So in this case, I'm using a feature layer. So I have the URL of that feature layer. I simply create something called a service feature table. So that basically represents the data source of that feature layer. And then I finally create a feature layer. So the feature layer will have things like the symbology that has to be used while rendering the data. And then I add that to the map as one of the operational layers. So after I'm done with all that, I just call this method called save. So I call map.save as async. So, and to this, I pass arguments like the portal, where I want to save this new map. And then I specify the portal folder, which specifies the location where I want to store it. Null means it will be stored in the root folder. And then some metadata like the title that I want to use, and then the tags that would be used whenever somebody does a search on the portal website, and then some of the data. So once I do that, it takes care of like sending this information and adding that as a new map in portal. OK. So now let me show you an example of how to create some of the portal item type for which we may not have, we don't have a direct mapping in our API. So an example would be like creating a PDF file or a CSV file or even a feature collection. So in this case, you will use the portal item API. And when you create a new instance of portal item, you can specify what type of item that you want to create. So for feature collection, you would just say portal item.type.feature collection. And then in this case, you also need to set the content explicitly. So the content could be binary data. Let's say if you're uploading a PDF file, then the content would be a binary data. In my example, if I want to create a feature collection, it would be JSON data. So I just pass in the raw JSON string. So for that, I need to use this type called portal item content parameters to specify the content. So once I have that, I can add that as a new item by calling add portal item on the portal user API. And if I want to update an existing item, I would call update data async, to which I can pass string data or binary data. And if I want to update some metadata like thumbnail, we also have an API for that. So in the demo, let's say I click on this features. So I have this file. I'm showing you the content here, which is basically JSON, which represents a feature collection. So once I click on upload here, it starts uploading that. And then once I go back to my browser and refresh the content here, let me refresh this again. So right now we see that we just added a new JSON file, and then it shows that the source is a feature collection. So I added that as a feature collection. So let me show you the source code for that. So in this case, what I did was, first of all, I had to create a new instance of portal item. And then I have to specify the type. So as a developer, you get to control what kind of type and data that you're going to specify. So you specify the type here. And then you specify some information like title and description and tags like that. So once I have created this metadata, I have to create the content. So for content, I'm going to use this API called portal item content parameters. And then I'm going to call this method called create JSON content. And to this, I can pass the JSON string that I want to upload. So once I have that, I would call add portal item async. And then to this, I would pass the metadata and the content that I just created. OK. So once you have created all these content, you may want to share this data with other users. So in this example, let's consider you have an organization of health department. And within that organization, you have two different groups, like a Medicare group and a health group. And let's say some member of a Medicare group created a new portal item. Now let's say you want to share this. So we have like 4 different levels of sharing. So once you create a new item from runtime, by default, we will use private, so nobody else can use it. And once you are ready to share it, the one option is to share it with only certain groups. So let's say I want to share it only with the Medicare group. So I can specify that group name and share it only with those users. So any other user won't be able to use it. I can also share it with the entire organization. So every member of every group that's there in the organization can use it. So we call that an organization share level. And finally, you can also share it with public. So this would be users who are not part of the organization. So they don't have to be a user within your own portal. It could be like general public who want to get access to that data. So in terms of API, you'd use the same portal item API. So you may want to, so if you're using an existing item, you may want to look at the current access level on that. So we have this method called getAccess, and that will show you what's the current access on the portal item. And if you want to share with everyone or the organization, you can call this method share with async and pass in appropriate flags for the everyone and organization. And if you want to share it with only certain groups, you can use this API, basically share with groups async. And we have an unshare API, which complements the share API. And then if you want to go private, you can simply call unshare async. So going back to my demo here, we created 2 items, and by default, they are private. So you can see the lock icon, which means they are private. So let me go to my Android app. I'll click on portal, and you can see these are the 2 contents, and right now they're not public. So OK, so let's say I want to make my map public, so I will click on this, and it just made a call in the background. And once I refresh this content again, you notice that the map the access level for that went is public now. So any user who has access to this link can now see the content of the map. So the code for that looks like this. So I'm simply calling this method called share with async and on the portal item. And then I'm passing this flag organization equal to true, which means which means share with everyone. Okay, so that was all the content I had about creating and sharing data. So just to give you an idea about the licensing for runtime, we have like 4 different levels of licensing. So if you're working with portal, and if you want to do only read-only operations, then that would work with light license. But in case you want to add or modify content, in that case you need to have a basic license to work with this. And then, so we just got started with all the sessions. We have like a great lineup of runtime sessions. So if you're interested in like data collection, mobile data collection is one happening today. We have a lot of focus on analysis and 3D stuff this year. So we have some sessions on that on Wednesday. And then if you'd like to understand the philosophy and the internals of how we build the runtime API, an introduction to API and an architecture tomorrow at 9 a.m. That's a very good session to attend. And if you'd like to see where we are going ahead with the runtime API, we have a session tomorrow at 2:30. And then we have a lot more sessions on runtime SDK until Friday. So so I think we are done with this presentation. We are open for questions.
All right, we take any questions if you have any. Who wants to go first? Come on. Everything can't be that clear. Is it that simple?
The function to create the query, is there available in all APIs, like the JavaScript and everything? The one that generates the query, like if you're querying or something?
The convenience, so the question is, are the convenience constructors for creating queries available in all APIs? Is specifically JavaScript? I don't know about JavaScript. I think they should have it. I'm not very familiar with it. All the runtimes have it.
Yeah.
Yes? What exactly does the load method do? That is a loaded question. Sorry for the bad pun. So that is a signal to us to say that we have to start loading metadata of that object. And if we need to connect to the files and read the files to get that, we'll do that. If we need to make a network connection to get that information from a server or a portal, we'll do that. So it's very explicit, right? We don't want to do these things as soon as you create an object. We want to let you as the developer control when you want to do that. So that's the explicit pattern of loading. But we also make it simple. So if you take a map that you just created with a URL and assign it to the map view will load it for you. We don't make it so explicit that you have to load it before you give it to the map view. So we ourselves are aware of what objects are loadable, and we'll try and load them when we can, whenever you call async methods or do other things with the API. But the loadable pattern is a way to just formalize when we go across the network or access things on disk. All right. Thanks, everyone. Hope you have a good, productive week.